Okay, in this lecture, we're going to start our discussion of human memory, and we're going to do so by giving you a little demonstration. I'm going to ask you to gather some thoughts that you have about memory. Then we're going to talk about some terms, and then we'll talk about the relationship between attention and memory because it's a pretty simple relationship, but it's an important one to address nevertheless. So what I want you to do is just take out a sheet of paper, and you can pause this video, read each statement here, and indicate how much you agree using the scale here. Strongly agree to strongly disagree, and if you don't know, don't know. So here are the 4 questions. I want you to pause the video here, take a moment and respond to them. Okay, I'm assuming you've responded to those questions, and so Lacey and Stark actually asked people, experts, and also the public to respond to these questions. So the human memory works like a video camera. So you can see the public has responded here. Now they've color-coded their output here. So blue is strongly agree, green is mostly agree. So if it's blue or green, that means they're agreeing, and if they're disagreeing, it's these red colors, right? And the don't know is purple. And you'll see that experts are totally disagreeing with that, but the public is fairly strongly agreeing with that. This is one thing that we will learn is that no, your memory doesn't work like a video camera at all. And we'll see a lot of evidence for that in some later lectures. The second question, once you've experienced an event and that memory does not change, public is doing a little bit better here, but they're still pretty much believing that it doesn't change, and that's just not true. We'll see lecture 14, we'll talk about distortions of memory, how your memories, once they're formed, can become distorted. Eyewitness memory. We're going to talk about eyewitness memory in that lecture as well. Unfortunately, the public does largely believe that one confident eyewitness is enough to convict a defendant. We're going to see why that's problematic. Really shouldn't use just eyewitness testimony or one eyewitness testimony to convict. Hypnosis. Some people actually believe that hypnosis can be a useful memory recovery technique. See, the public is still sort of believing in this. Experts know that this is not a good thing. It strongly creates distortions of memory. So these are some of the things that we're going to see. And I like this demonstration because I think it largely tells you that most of the time you're not, unless you've had a psychology class, you're not really in touch with how our memory works. So let's talk about some key terms here. And what I'm going to give you is a model of memory, but this is not a model meant to explain how memory works, but to define the terms and give you a sense of how information goes from the environment and through various stages in your brain. That's what I mean by information processing flow. This is sometimes called the information processing model. So we have stimuli in our environment. Might be words, might be images that you're seeing. You attend to those sorts of things. So again, we have to assume that there's some attention. We're going to talk about attention to memory here in just a minute. And then that information is, if it's attended to, is encoded. That is put into working memory. It's how events or information are perceived, thought about, or reacted to. And this is from Endel Tulving, who was a famous memory theorist, and you'll hear me talk about Endel Tulving's thoughts. But how events or information are perceived, thought about, or reacted to. Now this is happening. Encoding is happening in what's called immediate memory. Is a sort of a generic term. It used to be called short-term memory. We reject that short-term terminology because that just tended to indicate that it just held information for a brief period of time, but it does much more than that. It works with the information, so a common term is working memory. The working memory is associated with Badley and Hitch's model, and we're going to dive into that a little bit later in this course. So a more generic term is immediate memory. So it just holds information and works with that information for brief periods of time. As long as you're thinking about it, as long as it's in your consciousness, as long as you're using that information, it would be in your working memory. Some information is going to be consolidated. Some information in working memory will eventually be consolidated or put into long-term memory for more durable storage, right? So if you remember what happened last week in class, that information, whatever information made it into your long-term memory, was consolidated. sometimes you might write things down in your notes, or you might have some experiences and then forget about them entirely, right? In that case, the information was in your working memory. You were using it in the moment, but it never was consolidated, never was put into your long-term memory. Now, information in long-term memory can be retrieved. So retrieval here is a process. And when it's retrieved, it's taken out of long-term memory, put back into working memory so that you can use it. So if we're to ask you what's your grandmother's maiden name, chances are you weren't thinking about that. But when I ask you that question, you can pull it out of your long-term memory and you could write it down or you could say it out loud. That's in working memory is what's happening. Now, the retrieval, just like encoding, both of encoding, as we will learn, encoding and retrieval are processes. So these are things that we can do, and they're affected by the conditions that prevail at the time of remembering, right? Retrieval is conditions prevailing at the time of remembering. So the point here is that memory encoding and retrieval are active processes, which means you can modify them or improve them. And this is something that we're going to develop in detail. What we're going to do, the structure of the class is, today we're going to talk about, this video, we're going to talk about attention, but then we have lectures talking about working memory, and then we have lectures talking about consolidation and long-term memory and how it's organized, and then some that are focused on retrieval. So we're going to develop these terms as we go through the rest of the semester. So let's talk a little bit about attention and memory, and it sort of begins with, you probably remember this from your Psych 101 class whenever you had it, the dichotic listening test. So the way this works is you have somebody wear headphones and you play two different messages into the ears and you tell them to attend to one ear. So in this case, you're going to attend to this person's left ear and pay attention to the message, and then they test your memory for the message that you attended to. And what you find is if people ignore a message, they don't remember hardly any of it. The ignored input doesn't even make its way into memory. So in other words, you need to attend to information in order to remember it. Now there are some key small exceptions to this rule that we will talk about, but for the most part, in order to have memory, you have to attend to it, right? So without attention, exposure by itself does not create strong memories. So in order to demonstrate this, I usually have students, as a class, draw a penny. You've seen it a million times, so don't cheat. Try to do this. You can pause the video here in just a second, but I want you to just sketch out, draw a penny with all of the features on it to the best of your memory. So draw that out, pause this video, and then in the next slide, what I'm going to do is show you an actual photograph of a penny, and you can compare your drawing to that penny. Note how many features you got, how many you didn't get, what got distorted, that sort of stuff. And we'll talk about it, this demonstration in class. So here's your penny. Hopefully you didn't cheat. You probably got a lot of stuff wrong. That's fairly normal. And it's fairly normal because, again, if you're not paying attention, if you're not studying, this case, the coin, just an exposure to it, if you're not paying attention to it, you're not going to remember it with a lot of detail. So practice and attention. So one thing we know is that the more you practice, the more attention you will have to devote on a task, right? And so this is demonstrated in one study in particular, a set of studies, actually a lot of studies, but this is a real seminal piece of research, perhaps some of the best studies I've ever read. The Snyder and Shiffrin studies, 1977. And what they did is they had two kinds of tasks. They had what they called an automatic task, and an automatic task was didn't demand attention. And they had a controlled task which did demand attention in a visual search task. So I have a demonstration. Let me show you. Let me pop out real quick and sort of show you this. And you can find this demonstration in Canvas as well. So here's what they did. For the first task, they would show people a target frame, like set of digits. Then there would be a short delay with a blank screen, so they have to remember it, right? And then they get the memory frame, and they have to decide whether this digit was presented in the target frame. and they just simply respond yes or no. And obviously half of the frames would have a target and half of the frames wouldn't have a target. So if we go back, you see there was a 7 there, right? And so your answer here would be yes. Now this task involves detecting numbers from letters, and because they're subjects who are graduate students, were expert readers, they have a lot of history or experience detecting numbers from letters. This was a very easy visual search task, right? Didn't demand a whole lot of attention because reading had been practiced so much over their lifetimes. But they did another one, the controlled task. So detecting numbers among letters is automatic. They had another task though, where they get a target frame, which was letters, and you could probably see where this is going, a delay, and then you have to detect letters. So again, we'd have to go back and see, do any of these match, right? Any of those match? And the G matches, of course. So you would still respond yes, but that's much harder, right? That's a much harder task. So detecting letters among letters is a very attention-demanding, controlled search kind of task. So that's what they did. Let me go back to the presentation here and sort of explain the outcome of that. So anyway, they had those tasks. And if you ask people to do those tasks, what you find is people are a lot faster for the automatic tasks and slower for the controlled tasks. They also are more accurate, make very few errors for the automatic tasks, but the controlled tasks, they make more errors. Now, what was interesting about this study is they took their research participants and they had them do thousands of these trials. And after thousands of these trials, eventually they were able to do these controlled visual search tasks just as quickly and with the same accuracy as these automatic tasks. In other words, with a lot of practice, this attention demanding task became much more automatic, demanding a lot less attention. In other words, another way to say this or think about this is that practice automates parts of the tasks and frees up attentional resources. So the more you practice, the more attention you have to devote on that task. It's part of developing expertise for any task that you're doing. And this includes academic tasks, studying, learning how to solve problems, data analysis, reading graphs, learning to write code for computers, reading research articles. The more you do it, the easier it gets because some of the parts become more automatic. Another example of this practice in memory comes from Spelke, Hurst, and Neisser. I should have capitalized that. Whoops. And what they did is they tortured their secretaries in their psychology department. They asked the secretaries to take dictation. And so dictation is sort of a lost art. It's not needed anymore. But before computers and recording devices, people would dictate letters to their secretaries. And the secretaries would write down word for word what the person wanted in a letter. They would use a shorthand to speed their writing, but they would record what the person was going to say in this letter word for word, and they would later then go type it up and type up the letter for them. So they had these secretaries take dictation and read a novel at the same time. And then they would test their memory for, what was dictated to them as well as what they were reading in the novel. And after 20 weeks of practice, so this you can't imagine doing this, right? That would seem impossible. But after 20 weeks of practice, they could do it. The secretaries got good at listening to parts of the dictation, reading the novel, and sort of switching back and forth between these tasks. The practice automated parts of the task and freed up their attention and allowed them to do this. Now, these secretaries were not superhuman people. Practice has this effect. The other point I want to make here is we're going to talk about working memory tests a little bit later. This is kind of like a working memory task, but they're able to switch between the two tasks. That's very different than if you force them to do the two tasks at the same time. That's going to create different issues for us, as we will see. Remember the dichotic listening with Moray and Cherry and all them? Moray could actually shadow two conversations at one time after he practiced a lot. So if you practice, you can kind of switch between the attended and unattended channel and hear the message and retain the message as well. So practice automates parts of the test. In class, we'll talk about other examples where practicing sort of automates parts of the test. But the takeaway here is that with the practice, it frees up attention. And if you free up that attention, that can be used to learn new other information. So that's the key takeaway here. Now, the other thing I want to talk about really briefly is that practice can also create what's called procedural knowledge or procedural memory. Sometimes it's called skill memory. So, like if you're practicing riding a bike or driving a car with a manual transmission, a lot of practice happens and you gain a lot of knowledge from that experience or that practice. But this is a different kind of information, it's a different kind of memory, as we will learn later in the semester.